everyone, welcome back to the channel. So today in this video lecture we'll be solving this problem, binary tree right side view. So this is a Leetcode medium problem and is frequently asked in a lot of interviews. So in this problem we are given a binary tree. So a binary tree is basically a special type of tree where each node of the tree may have at most 2 child nodes. So imagine yourself standing on the right side of the tree. Return the values of the nodes you can see ordered from top to bottom. That means we have to return the right side view of the given tree. Like here in this example, if I am standing on the right side of this tree, then the nodes which are visible from that view will be 1, 3 and 4, and I will return them in the same order from top to bottom. So 1, 3, 4, I will return them in an array. So that I have to do in this problem statement. So let's better understand the problem statement using an example or a better example. So like here in this example, what will be the right side view? So imagine yourself standing on the right side of this tree, that is over here. So you are looking from this side. Here if you see, the nodes that will be visible to you would be 1, 2, 1, 3, 4 and 6. This node will also be visible. So we got to print these nodes in this order. So how would I get to print this order, the right side view of the given binary tree? Now one of the ways is simply do the level order traversal, that is perform BFS. So while you perform BFS, always push the right child first. So traverse the nodes like this, from right to left, then this level from right to left, then this level from right to left, finally this level from right to left. And the first node at each level will be stored in an array containing the right side view, and that will be my answer. But here in this video lecture I will be solving this using a recursive traversal. Okay, how? Let's see that. Now if you know what is a in order, pre-order and post-order traversals, then you will be able to understand this problem well, because this is nothing but if I just perform the pre-order traversal, that is root, then right child and then left child. If I perform this traversal, like for any node, traverse the root, then traverse the right child and then traverse the left child, then I will be getting my right side view. Let's see how. So we are starting from node number 1, traverse this node, this is the root node, and this is also the first node for the right side view. So I will push this node into the answer array. Now traverse the right child, it would be 3, traverse this child 3 and also push it into the result. Now traverse its right child, that is 4, and push it into the answer array. Now from this node 4, I do not have any child node for node number 4. So just go backtrack to node number 3. From here backtrack to node number 1. Now from node number 1 move to node number 2, which is the left child. Now from node number 2 move to its right child, which is 5. So now I am moving to right child, but if I simply keep pushing the right child for every node, then I would push this node again. So I would have 5 here, but this is not present, this is not visible from the right side, so I cannot push this node into the answer array. So to avoid this condition, I will simply mark every level. Like here, this is, let's say level is for the root node, the level is 0. For this level containing node number 2 and node number 3, the level is 1. For this the level is 2. So for each level I am simply pushing only one node, which is the rightmost node. So I have already pushed the node for level 2. So I will not push this node into the answer. Okay, so I have already pushed the node for level 2, which is node number 4. So I'm not gonna push the node for that level, because for each level I am just pushing exactly one node. Fine. So here the level is 0. The answer array is do not contain any element. Okay. So I will push this element into the resultant array. Then I will move to the right child. The level will be 1, and here the size of the array is also 1. Okay, the level is also 1 and the size of the answer array is also 1. So I will push 3. Then from 3 I will move to node number 4. Here the level is 2 and the size of the array is also 2. So I will push 4. Then I will backtrack to node number 1 and I will come eventually to node number 5, where the level is 2 and the answer array already contains 3 nodes. Hence I will not be pushing this node into the answer array, because I have already pushed 3 elements for 3 levels. Okay. Now I will move to next level, which is this one, which is level number 3, and obviously the level here is same as the size of the array. That means this I am visiting the next level. So I have to push this node into the answer array. So I will push 6 here. Fine. That means for every level push exactly one node, and that node has to be the rightmost node on that level. So traverse the given tree in this order: root, right, and then left, and keep a answer array which will store the right side view of the given binary tree. And if the level at any node is same as the size of the given array, then you have to push that node into the answer array. So let's see how it will work. So imagine a function. So let's call the function a helper function. So in this helper function we'll have 3 things. First is node, the second is level, and the third is resultant array. Okay. Now initially the level is 0 and the node is this root node. So we do not have any element in the resultant array, so we will simply push node number 1 into this array. So I'm going to push node number 1 here, because the size of the resultant array is 0 and the level is also 0. That means on level number 1 I haven't stored any node, and my first priority at any level when I'm moving from level L to L plus 1, the first priority is to visit the right child. So here the size of the resultant array is same as the level, so I'm going to push this element into the answer array. So now 1 is there and the size of the resultant array becomes 1. Now as per the priority I will simply traverse its right child, which is this one. Now I am at level number 1. That means the size of the given resultant array is same as the level. That means on the level on where I am standing, I haven't pushed any node. So I will push 3 into the answer array and again traverse its right child recursively. Now here the level becomes 2 and the size is also 2. So simply push this node into the answer array. So we'll have 4 again. Now backtrack to 3, then to 1. Now from 1 traverse the left child. Now from the left child I can see that here the level is 1 while the size is 3 now. Means I have already pushed the appropriate node for level number 1. Now traverse its right child, which is at level number 2. And the size is 3. That means I have already pushed the appropriate node for this level. Now traverse the next level, this node, which is the left child of node number 5, because it do not have any right child. Now here the level number is 3, which is same as the size of the given array. That means I haven't pushed any node for this level. So this is the node which I will be pushing. So push 6 and return from here. And this is my answer array. It will have 1, 3, 4, 6. This is the right side view. So I hope you got the idea. Let's jump to the pseudocode implementation. So this is the node structure. For any tree node, we have three elements: the value, the left pointer, and the right pointer. And here is the helper function, which takes in the node, the resultant array, and the level for the corresponding node on which I am standing. So if the root node is null, return right from there. Otherwise, if the level on which I am standing is same as the size of the given resultant array, that means I have to push at least one node from this level, and I simply push the current node into the resultant array. Now from the current node, I will move to the right child. So I will call this function recursively for the right child, while the level will increase by 1. And after that, I will call the same function for the left child, and the level will increase by 1 again. So this is nothing but a traversal where I traverse root, then right child, and finally the left child. So I hope you got the idea. Let's jump to the code implementation. So let's implement the solution. Let's take this helper function, which basically helper takes in the recursive function, which takes in the node, so tree node, and it takes in the level, and it takes in the answer array. Now here, if the node is null, then return from here. Otherwise, check if the size is same as the level, then push this current node into the answer array. So push the value for the current node, recursively call the same function for the right child, and increase the level by 1, and call the same function for the left child, increase the level by 1, pass the answer. Fine. So here in this function right side view, create this vector resultant. Now pass in the root, the level which is 0, and the resultant array. Finally return this resultant array at the end of this function. Let's just try to run this code. Okay, we have to, I'm calling helper function here. Okay, let's submit it. Okay, it got accepted. The time complexity for this solution is same as the time complexity for depth first search, which is big of n, and the space complexity is big of h, where h is the height of the given binary tree. And in the worst case, the tree can be like this, a skewed binary tree with n nodes, and in that case the space would be big of n, and this is the stack space. Okay, so this is the stack space which is big of n, and the time complexity is also big of n. So that's all for this video. If you want to find the left view of the binary tree, then the approach is very similar. In that case, the traversal would be root, left, and then right. Fine. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel, and stay tuned with me, and I hope to see you all in my next video.